Hello and welcome to XC Psychology. Today we're going to figure out what makes an atom becomes an ion. So now we have our natural sodium in here. And if you remember from last episode, the red represent protons with positive charges and the blue represent electrons with negative charges. Now each row we have 5, right? 1, 2, 3, 4, 5. So here we have 11 protons and 11 electrons. Now the net electrical charge, very simple, is the number of protons minus the numbers of electrons. So currently, for the neutral sodium, we have a net electrical charge of 0. Now, things get interesting when, if you notice here, something is missing, right? So now we still have 11 protons, but at the time, we only have 10 electrons. We lost 1 electron. Now, based on this formula here, we have a net electrical charge of 1. Hence, if you look at this sodium ion chemistry notation here, it has a little plus there. And ions with positive charges are usually called cation ion. This because cats are cute and they are very positive. Now let's have a look of our chlorine. Chlorine, here we have 1, 2, 3, 4, 5 in each row. 3 rows here, so 5 times 3 is 15. It is 15. And plus 2 is 17. So we have 17 protons and 17 electrons. And currently, with the equal number, the net electrical charge is 0. Now, if we look down here in this section, we've got something more here, right? So we still have 17 protons, but now we have 18 electrons. Remember, the net electrical charge is the number of protons minus the number of electrons. So now 17 minus 18 is minus 1. So you can see now we become chloride ion, and chloride ion notation has a little negative on it. And we call the negative charged ions anion. And I talked extensively about cation and anion in Module 1, Episode 8. So if you want to have a look, please dive in there. So quick summary for this section. How do atoms become ions is by gaining or losing electrons. So for those curious minds out there, you may ask the question, why only electrons move? Well, technically, protons can also move, but if you remember our last episode, protons defines element. When the protons move, the identity is completely changed. And so in biology, we don't have to worry about protons moving. Just remember in biology, protons do not move. Another way to understand it is if you remember our last episode's ice cream truck and our little penguin here, right? And remember, ice cream trucks are very heavy and penguins are light, so it's easier for them to move. And also remember, a proton is about 1,838 times more massive than an electron. So the next question will be, what makes electrons move? If your answer is ice creams, for me, I will give you a pass. And if your answer is attractions, I will also give you a pass. But the answer is actually stability. So remember in our very first episode, we said that atoms are very balanced creatures. They love balance and they want to reach stability. And how? Let's find out. we have something called valence electrons. Basically, valence electrons is electrons in the outermost layer of an atom. And if you look at this one, we have a neutral sodium atom. So remember, we have 11 electrons in total. So we have 2, 1, 2 in the first layer. We have 8 in our second layer, and we have 1 in our outermost layer, or the third layer. And here we have the electron configuration. As you can see, is from the innermost layer to the outermost layer. So 2, 8, 1. This is what we call electron configuration. And the one on the outermost layer is called valence electron. They're the most likely to be lost. And why? There is a concept that's called electron shielding. So imagine everyone is attracted to the miraculous and charming and interesting protons. So the one is close to the protons, for example, this one, will feel the most attraction. And the one on the second layer maybe still feel a lot of attraction, but maybe not as much as the first layer. And with all of this attraction happening on the second layer, it's kind of create a shield. So the attraction from the valence electron to the proton will be very weak. And so it is very easy for the sodium atom to lose this electron and become sodium ions. Well, let's have a look at our chlorine atom. And for a typical chlorine atom, the electron configuration is 287. So which means in the outermost layer, it only has 7 electrons. And we can see 1, 2, 3, 4, 5, 6, 7. And one thing atoms love to do is to fill their outermost layer. I know some people, talk about the 8 rule or 288 rule, but that only fits like about 20 something elements in the periodic table. So for now, let's remember that we want our outermost layer to be stable, so we want to make it a bit full. And so chlorine atom, as we discussed in the previous section, we will have 1 extra electron to become chloride ions. Now, what is the common theme between these two? Right? The common theme between these two is that after the sodium atom lost an electron, it becomes very stable. Why? Because then the outermost layer is gone. We only have the secondmost layer, and it has 8 electrons. And what happens with the chlorine atom to chloride ions is that it gained 1 electron and filled the outermost layer, and now it has 8 in the outermost layer, and it becomes more stable this way. And so the stability is achieved by losing or gaining electrons. And speaking of which, because, it is such a coincidence that one of them wants to lose one of them wants to gain one. So together, they form something special. And we call this process ionic bond, right? It's kind of like we're bonding. So what happens is sodium's like, you want one? I really don't want another one. Chlorine says, sure, why not? I will take one. By the way, I know the image is not extremely accurate, but just trust the electron configuration down below. And now we have sodium says, I'm happy now. Let's just make it 8. I have 8 electrons here. And chloride ion is also happy. Oh, I also have 8, right? Also have 8 here. And so with ionic bond, they together form ionic compound. That's our table salt. And table salt is 90+% sodium chloride. So there's another way to achieve stability. And again, it is by sharing. So we have our hydrogen here. Right? Hydrogen is a very simple form. It only has one electron. And then we have our oxygen here. And for oxygen, it is a true 6 for the electron configuration. So what is water? H2O, right? And so how do they form? Let's have a look. So I've already put up the image. I've made the electrons that are sharing between the hydrogen and oxygen to be a bit darker blue. And well, everything else kept the same. Now, oxygen is happy because it filled the outmost layer with more electron, and it also has 8. And hydrogen is happy because, it's got a new friend and very close to it. So together they form the water molecule. And this is what we call the covalent bond. And the covalent bond creates covalent molecule. So the key takeaways of today: how do atoms become ions? By gaining or losing electrons. Protons stay in the molecules and determine the atom's identity. Valence electrons are the electrons that are most likely to move. Remember, the outmost layer, most likely to move because of the electron shield. And there are 3 ways atoms become stable: by losing electrons, and we become cations, or gaining electrons becomes anions, and then by sharing electrons to become molecules through covalent bond. So coming up next, we just learned that, sodium atom becomes sodium ions by losing an electron, and chlorine becomes chloride ion by gaining an electron, and together, through the ionic bond, they form a compound called sodium chloride, which is our table salt. But here is a mystery. If our bodies are full of sodium ions and chloride ions, is there table salt floating around in our blood? Stay tuned for the answers in the next episode.